So we started with our chapter that was our nanochemistry, right? And in that we have so far learned that what is meant by the nanomaterials, right? So basically in any of the materials in which one of the dimensions out of the three dimensions, that is your x-axis, y-axis or the z-axis, any one of the dimensions, if it is lying in the nanoscale range, that was in the range of the 1 to the 100 nanometers range, it was lying, the particular material we were referring it to be the nanomaterials, right? So in the last class we have looked upon to the what is the basic definition, basic portion of it we have learned, and we have seen about its preparation methods, and we have seen the characterization of it. Various properties also we discussed, and we have seen the characterization of it. That is, if in the labs, if these nanomaterials are being prepared, how using the different techniques we can detect that this is the particular structure of my nanomaterials. Now what we are going to look upon is the working of these techniques. We are going to look upon mainly four to five of the techniques we have to focus that are majorly used to study about the nanomaterials. It will be including your SEM, that is your scanning electron microscope. We will be looking upon to the transmission electron microscope, and then to the tunneling microscope we will be looking upon to the AFM, that is your atomic force microscopy technique, and the X-ray diffraction. So majorly these five techniques we are gonna focus upon one by one. So the first technique now we are gonna start is, that is your SEM, which is your basically scanning electron microscope. Okay, so first technique is my SEM. It stands for the scanning electron microscope. Scanning electron microscopy, you can say. This process is called as this microscopy, and the instrument which is being used, it will be called as your scanning electron microscope. Okay, so in the scanning electron microscope, I have told in the last class that it is basically used to study about the surface morphology of the nanomaterial particles. So what is meant by the surface morphology? So suppose, imagine this is my nanomaterial. You have to imagine that, consider any one of the dimensions or all of these three dimensions are lying in the nanoscale region. I have to predict that what is the surface of it. It is seen to be the planar in the structure, but in actual, imagine some different nanomaterial it is present, and the structure or the surface of it is not the planar one. I have to predict that what is the actual structure of this nanomaterial, that is its outer structure. If I have to predict, for that we make use of the scanning electron microscope, right? So basically scanning electron microscope, it is a powerful technique which is used to study about the surface morphology. By the morphology of the surface, it means the outer surface of the nanoparticles you have to predict. Okay, so it is based upon the principle that when this sample surface you have to detect. For this, what you will be doing is you make use of the fast moving electron beam which strikes over this sample surface, and a new beam of the electrons is being generated which is detected by our detectors. So what is the basic principle? That in the scanning electron microscope, a primary beam of the electron. So the beam that you will be striking over the surface of your sample, it will be called as your primary beam of the electrons. So the beam that is striking will be the primary beam, and after striking over the sample surface, a new beam will be produced. That will be called as the secondary beam of the electrons. This is what I have written, that in the scanning electron microscope, a primary beam of electrons is used for scanning the surface of the materials. The primary beam, it interacts with the sample and produces the secondary beam of the electrons which is detected by the detectors. So this is the basic principle behind it. So one beam I am striking over it and the other is being produced, that will be detected by my detectors. So how does this SEM actually looks? This is the layman structure of it that I have drawn for you. So in the above, it is basically the above this box, it represents the source of the electron beam, that is an electron gun basically it is representing, which is gonna produce a fast beam of the electrons. So this is basically your electron beam source. Electron beam source. So the primary electrons, it will be produced with the help of your electron beam, right? So now this fast moving electrons that has been produced, they will be going in a straight line through this. So these are basically now it after being produced from the electron beam, these electrons, they are passed through the lenses. First lens that it passed through is called as the condenser lens. It passes through the, this is the, this particular species is my condenser lens. Condenser lens. And it again it passes through one more lens that is called as the objective lens. It passes through the objective lens, right? And here these coils are attached, that is called as the scan coils. That means on these lenses coils have been mounted, that is called as your scanning coils, okay? And this beam of the electrons, after passing through these detector, it is the striking over to the sample surface. So this contains my sample, and after striking over this, a secondary beam of these electrons is being produced. This is the beam which is passing through the detector, and on the monitor which is attached with the detector, you are able to see the sample structure. Basically you will be able to see over there. So this basically is the screen where it will be showing the image of the sample. It will be showing you the image of the sample. So now let us see one by one the role of each of these components that we have labeled in this particular microscope. So first we have seen that it is your electron beam source, or we call that it is my electron gun. So first is electron beam source, or it is my electron gun. So by this, what you are doing is you are producing a fast beam of the primary electrons, right? So this is basically used, it is used to produce a fast beam of the electrons. It is used to produce a moving beam of electrons. So these electrons you have prepared, beam of electrons. So these electrons you have this electrons are being produced over by this electron beam source. So basically the source that you are using to prepare this primary beam of the electrons is generally the thermionic emission guns are basically used for it. So basically the gun that we generally use to produce the fast beam of electrons is your thermionic. It is called as thermionic, related to the word therm, that is the heat. Thermionic emission gun is generally used